Hey, what's up, Internet? Super exciting day 2 of Interface Digital Health Summit here.
Absolutely.
I'm with Derek Mathers, who just came off stage. He is a business development manager at Worrell Design in Minneapolis, Minnesota. And maybe even more interestingly in some ways, he is a professor, adjunct professor of 3D printing at the University of Minneapolis, right?
Yes, sir.
Awesome, man. Tell me, you just kind of blew everyone's minds. Like, we've all seen, 3D printers. We've seen the MakerBot.
Yeah.
And we've started to see some of the knickknacks that our friends are starting to pump out and stuff.
Absolutely.
If people have a little bit deeper understanding, they may have seen like at the Oreo project where they like 3D print your own flavor of Oreos and stuff. But this is some next level stuff. So
Yeah.
tell us a little bit about some of the themes you're exploring up there in terms of the future of 3D printing in our bodies.
Yeah, well, the key themes are really being dictated by the machines that people are making. People are creating different sorts of 3D printers that can print like soft conformal electronics, like we're doing up at the University of Minnesota in Mike McAlpine's lab. People like Worrell are using multi-jet printing to build molds so that you can get medical devices quicker in their spec material to check all the boxes for the FDA when you got to make it in your spec material it's going to be produced in. So we're looking at all these different types of threads that are out there. I think one of the most fascinating is the fact that Carbon 3D is about to be entering the market with a machine that can print wicked fast with incredible material properties that in some cases are better than injection molded parts, and they're cured incredibly quickly, sort of like Terminator 2 style.
So let's dial this back a little bit, because there's going to be a lot of technical people here who totally get what you're talking about, and my mom also watches this video blog. So
awesome.
we're talking, the idea here is that with a device the size of a refrigerator, you can now print almost anything you can conceive of in a variety of materials, like hundreds of different materials, from metal to wood, plastic, polymers, and even organics.
Ceramics, glass.
Organic materials?
Oh yeah, organics.
Like what?
Interesting organic materials like UCSD, so UC San Diego, perfect place to design a microfish design.
Yeah.
Well, they're actually developing this biocompatible soft durometer organic material that I think is technically a plastic, but what they do is they'll literally swim through your veins to deliver drugs to exactly where in your body you need those drugs to get delivered to.
That's
incredible. Right now you take a pill or you take a shot and they try to get it where you need it, but through this they can literally calculate in the algorithm before it's built how it needs to degrade in your body to get exactly where you need it.
At a conference like this, it's sort of inevitable that things like trend towards, science fiction, Star Trek, the tricorder device. There's a guy walking around yesterday that's like, in the future, I think we'll only need doctors for childbirth and accidents, and and so I was thinking about that a little bit. And then, you talked about something up there with the ability to build stints that you can regrow nerve cells on, and the example of the paralyzed mouse.
Exactly.
So tell me about that one.
So the cool part about 3D printing is that well, maybe not the cool part, but as important to the output of being able to make certain types of materials that can encourage the body to regrow where it wasn't previously able to, by matching the human anatomy. The interesting part about it is that the inputs are equally as important. So in, again, another example from Mike McAlpine's lab, I hate to belabor Minneapolis right now, but just a week ago he announced a process where you can actually print the scaffold, and you can print chemical, I forgot the technical term that he uses, but you can print chemicals into that new scaffold that encourage the nerve to regrow, where previously, like my injury in football in high school, where my spine was separated and it had to fuse back together, you can literally help those nerves grow back together, and they had success in helping those
paraplegic mouse was given the ability to move its limbs once again.
Yeah, and in full disclosure, the mouse wasn't walking around so well, but it was no movement to some, and so it's like, that'll get vetted out in future trials.
Well, we know that we have a human ability, amazing human ability to regenerate, but that there's certain things we can't do, and we can't quite figure that out. Why is it that we can regrow the tip of our finger but not the whole finger? If we were able to give the organic material structure to support to grow out, maybe what could we be able to do in terms of regeneration, regrowth? And you guys are exploring the periphery of that with 3D printing.
Yeah, absolutely. That's funny you say periphery, because it was peripheral nerves as well that they were regrowing.
Cool. Yeah.
But yeah, it's exactly
little science puns thrown in for everyone.
Totally,
Awesome. Well, I really appreciate you sitting down and talking with me. Your talk was totally inspiring. You got mobbed when you came off the stage.
Thanks for
people
having
really
me.
perked up and stuff, man. So
well, I'm perked up to be in Vancouver. I've never been here before, but this has to be the most beautiful city I've ever been in.
Awesome.
I went to Monterey, this awesome little surf school, CSUMB.
Yeah.
And this is like a huge Monterey with like even a bigger aquarium.
Is that the banana slugs?
No, it's Santa Cruz.
Okay,
but we would always go up to Santa Cruz. Great reggae concerts there.
Just down the road.
Absolutely.
All right, good stuff, man. Well, KK signing off from Interface Digital Health Conference. Over and out for now.
Later, guys.